question for you. What's the cosine of 30 degrees? Or you could say cosine of pi over 6 if you want to talk radians. Let's just talk about it. The cosine of an angle, cosine of some angle theta, is equal to the adjacent side, the side that's adjacent to that angle, the leg adjacent to that angle, divided by the hypotenuse, correct? Okay, fair enough. So the cosine of an angle, let's find the cosine of a 30-degree angle, and we're going to do it on our unit circle, right? So if we had a little triangle right here, which we had in a previous part, right? See, you with me? Cosine of 30 degrees would be, well, the adjacent, which appropriately is labeled with an A, which we found to be square root of 3 over 2, all right? Square root of 3 over 2. And we're going to divide it by the hypotenuse. Well, the hypotenuse is 1, because we are on the unit circle. And so, let's see, anything divided by 1. Well, the cosine of 30 degrees is square root of 3 over 2. Oh, well, there it is. Okay, so the cosine of 30 is square root of 3 over 2. Huh. I wonder what the cosine of 60 is. Do you see where this is going? If I want to know the cosine of 60 degrees, then I would say, all right, well, I'd pick the adjacent side. If I have a triangle right here, the adjacent side, and this distance right here, a little triangle that I don't want to draw and mess my picture up, but it would be this, which would be 1/2, divided by the hypotenuse, which would be 1. So the cosine of 60 degrees is 1/2. So this is not a proof, but it's a really good demonstration that the cosine is going to be square root of 3 over 2 for 30 degrees, or 1/2 for 60 degrees. Check it out, for real. It's kind of cool. If I am in degree mode, and I want the cosine of 60 degrees, 1/2. Who knew? Isn't that great? Cosine of 30 degrees is that. That's square root of 3 over 2. Told you. Ah, all right. So here's what we just discovered. The cosine is the x value. That's going to come in handy to know. All right. I wonder what the sine value is. You can figure this out. You're smart. So we're going to do the same idea here. Let's do sine. And so the sine of some angle is equal to the opposite divided by the hypotenuse. And we'll do the same idea, and let's just do the 30, 60, 90 degree thing going on here, which we already had. There it is. And opposite of the 30 is 1/2. So the sine of 30 degrees is 1/2 divided by the hypotenuse, which was 1. Okay, no surprises. The sine of 30 degrees is 1/2. Oh, that must be the y value. I wonder what the sine of 45 degrees is. It's the y value, same as the x value in this case. I wonder what the sine of 60 degrees is. It's that. I wonder what the sine of 90 degrees is. It's 1. Check it out. Sine of 90 degrees is 1. Told you. All right, there we go. Big idea. Big idea. The x coordinate is the cosine of your angle, and the y coordinate is the sine of your angle. And so if I ever say, hey, what's the cosine of 135 degrees? I said cosine, you're thinking x value. I said 135, negative square root of 2 over 2. That's it, right? All right, well, there's one more. It's tangent. I'm going to go off on a tangent. Sorry, I couldn't resist. That was terrible. Absolutely terrible. So here goes. If sine of an angle is opposite over hypotenuse, and cosine of an angle is adjacent over hypotenuse, then this is neat. If I just, because I feel like it, took sine of an angle and divided by cosine of an angle, then I would have opposite over hypotenuse divided by adjacent over hypotenuse, and yes, your hypotenusi can cancel, and you'd have opposite over adjacent. Okay, so when I first started writing these, you were like, well, aren't you going to write tangent? Oh, sure, I'll squeeze it in here. Tangent is opposite over adjacent. There you go. Tangent is sine over cosine. Tangent is sine over cosine, which is y over x. Oh my goodness. Oh my goodness, this is so delicious. Let's write it down. Tangent of my angle is equal to sine of my angle over cosine of my angle, which is equal to y over x. Now, I can say, what's the tangent of 30 degrees? And you would say 1/2 divided by square root of 3 over 2, and you have to figure it out. How about we figure them all out right now real fast? And then we'll have tangent on here. Mine are going to be in purple. Looks very similar to the blue in this, but we'll work with it. So I'm going to go all the way around, and we're going to find tangents as well. Tangent is going to be y divided by x. 0 divided by 1 is 0. Okay? 1/2 divided by square root of 3 over 2 is sloppy. Let's do it. 1/2 divided by square root of 3 over 2 is the same thing as 1/2 times 2 over the square root of 3. The 2's would cancel, and it leaves me with 1 over the square root of 3. Nobody likes radicals in the denominator, so we multiply by the square root of 3 over itself. That gives me square root of 3 over the square root of 9, which is square root of 3 over 3. That was a lot of work just to find out that this is the square root of 3 over 3. Okay, let's do this one. Trust me, it's easy. Square root of 2 over 2 divided by square root of 2 over 2. You can represent it differently and be like, oh, that's something divided by itself. It's 1. Okay, square root of 3 over 2 divided by 1/2. Square root of 3 over 2 divided by 1/2. That's the square root of 3 over 2 times 2 over 1. Cancel the 2's. It's going to give you square root of 3 over 1. That's the square root of 3. Okay, 1 divided by 0. 1 divided by 0. That's not a thing. That's undefined. Are we going to do this all the way around the unit circle? Oh, absolutely not. Absolutely not. These are the same, right? Only the signs are different. So if we did y divided by x, we'd get the same thing, only with an opposite sign. You see what I mean? Square root of 2 over 2 divided by negative square root of 2 over 2. Oh, well, they're the same thing with opposite signs. Same thing with opposite signs. 0 divided by negative 1, well, not an opposite sign here, it's just 0. Okay? Y divided by x is going to be same as this one. Lights just went out. Y divided by x is going to be same as this one, but the signs are the same when you divide, so it's positive square root of 3 over 3. Here we have positive 1, positive square root of 3, still undefined. Here we have negative square root of 3, negative 1, and negative square root of 3 over 3. Okay, one more thing I want to show you, and we're going to put it down here in the bottom. And we're going to talk about where sine is positive, cosine's positive, tangent's positive, that sort of thing. So down here, I'm going to put it in the bottom right, big plus sign. This is going to be where things are positive. And this is a very commonly used acronym here. In the first quadrant, cosine, the x values are positive, sine, the y values are positive, and tangent is positive. They're all positive. So all are positive. Okay, let's come over here to quadrant 2. In quadrant 2, let's see, cosine's negative, sine is positive, tangent is negative. So over here, only sine is positive. Okay, we come to quadrant 3, and in quadrant 3, cosine and sine are both negative, and tangent is positive. And in this quadrant, the only thing that's positive is the x values, which would be cosine. So as we go around this and we say, well, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. I'm not going to write it down because it's not a true statement, but it is a good way to remember it. We can use the first letter of each of these, 1, 2, 3, and 4, ASTC, and the acronym that helps a lot of people is all students take calculus. That is not true. However, ASTC, all students take calculus, will help us remember where things are positive.